Okay, now I'm on page 2 of my Algebra 1 review sheets. So, problem number 20. These are literal equations, so we want to get x by itself. So, in order to do that, I am going to take, well, let me recopy my equation out here to the side. I've got a couple of options. I'm going to subtract c from both sides. So I get negative c plus g equals negative x. So since x isn't by itself yet, I have to divide everything by negative 1. And now I've got x by itself. Negative c divided by negative 1 is positive c. G divided by negative 1 is negative g equals x. So this is one of the possible answers. And again, I told you your test will be multiple choice, so if that's not one of your choices, then you might look around and see if their order is switched. In number 21, I want to get a by itself, so I'm just going to subtract c from both sides. So g minus c equals a. In number 22, absolute value equations, we want to get the absolute value by itself, which it is, and then we have to do that thing where we realize that absolute value equations have two different answers, one that's positive and one that's negative. And so once we split the equation, then we can solve it, and we get negative 3n equals negative 6, divide by negative 3 on both sides, so here I get n equals positive 2, and then here I'm going to subtract 9, and then divide by negative 3 minus 9 is negative 12, divide by negative 3, and I get n equals positive 4. So the two solutions for this one are 2 and 4. In number 23, before I split my equation, I want to get the absolute value by itself. So I'm going to add 5 to both sides. Now I get n over 8 equals negative 4 plus 5 is 1. Now I've got my absolute value by itself, so now I can split my equation. N over 8 equals 1, n over 8 equals negative 1. So in this one, when I multiply by 8 on both sides, I get n equals 8. On this one, when I multiply by 8 on both sides, I get n equals negative 8. Always two solutions, almost always two solutions to an absolute value problem. Now we're getting into slope and graphing. So if we're given a picture of a line, they give us two dots, and for a picture it's easiest to use rise over run to get the slope. So I can go up 4 and to the right 2, so that's a positive 4 and a positive 2. My slope there is 2. But if they give me two coordinates of points and ask for the slope, then I want to use my slope formula, which hopefully you've got memorized by now. So y2 minus y1 over x2 minus x1. So y2 is negative 4 minus y1 is negative 10. You see how carefully I am substituting this. Negative 11 minus negative 15. And you can use your calculator if you need to make sure you don't have a mistake on your negatives. So negative 4 minus minus 10, we know that subtracting a negative changes into addition, so that you get 6, and then negative 11 minus minus 15, that's positive 4. And so that's going to reduce like a fraction into 3 halves. In number 26, I want the slope-intercept equation of the line. So we're going to look at the intercept and see where it crosses. So slope-intercept form, remember, is y equals mx plus b. So I can see where it crosses, and I know that b is negative 3. Then I could find another point on the line that's not in between two grid markers. So I can go up 3 and over 1. So that means my slope is 3 over 1, or simply 3. And now I'm ready to write my equation. So I'm going to do something similar over here, except I'm going to notice in number 27, my line is a vertical line, So the format of an equation of a vertical line, I simply look at the x value. See, it never crosses the y-axis, so there's no y-intercept. There's no y in this problem at all. So x equals -5 is the format of a vertical line. In number 28, we're not given a picture, we're just given an equation in standard form. So when we're asked for slope-intercept form, that's where we know we've got to get y by itself, and then we want to put equals some coefficient times x, and then if there's a constant, that'll go at the end. So to get y by itself, we want to subtract 11x from both sides. And then I see that 36 minus 11x, those are not like terms. So I'm going to go out to the side here, and I'm going to say, okay, I've got 6y equals -11x plus 36. Put the coefficient with x first, and then divide everything by 6 and simplify if I can. Y equals -11 6x plus 6. In number 29, I'm going to go over here and write this to where I have enough room to work out the problem. And again, start moving things away from y. So I get 7y equals, and these are not like terms, that's how I remember they don't get to be combined. I don't want to lose any of those negative signs, and now I can just divide by 7 everywhere. -15/7 doesn't really reduce, but that's okay. But 49/7 is equal to -7. In number 30, I'm being asked for slope-intercept form of the equation, but this time I'm being given the slope and the intercept, so I am just going to substitute. Here my slope is -7/4. Here my intercept is 5. So after I've substituted, I am done. So now we're ready to go on to the next page. And some more slope-intercept equations. This time we're given a point and a slope. So we're going to recall that we have this thing called point-slope form, and that is this equation. Y minus y1 equals m times x minus x1. So our point, so remember, ordered pairs are always x comma y. So this is going to be x1, y1, and here's our m. So when I go through the formula, y minus y1 is 1 equals slope times x minus, and then x1 equals 4. But they don't want us to keep it in slope-intercept form, point-slope form. They want us to move it into slope-intercept form. So that's where we have to distribute and move some things around. So first thing, I'm going to distribute that 3 halves, so 3 halves x, and then 3 over 2 times minus 4, 3 over 2 times -4, that's -6. And I want to add 1 on both sides just to get y by itself, and I get y equals 3 halves x. -6 plus 1 is 5. And then in number 32, I'm going to do it the same way. I'm going to go y minus -1, so minus 1 turns into plus 1, equals the slope times x minus -5. Again, that turns into a plus. But I need to get this in slope-intercept form, so I'm going to distribute right here. So y plus 1 equals 2/5 x. 2/5 times 5 is 2. And then I need to get y by itself, so I'm going to subtract 1 on both sides, and I get y equals 2/5 x, and then 2 minus 1 is just 1. In number 33, I'm going to do the same process, except I have a little bit of work to do from the beginning to get my slope. I have to plug that into the slope formula, which, remember, it's subtract the y's and divide by the x's. So, y2 minus y1, that's negative 5 minus 4 over 0 minus minus 1. So negative 5 minus 4 is negative 9. 0 minus minus 1 is 1. So now I have my slope. I have a point. So let's go and plug it into point slope. Y minus, so which one of these points is going to be y1? Well, the truth is it doesn't matter. So I'm going to pick this one. Y minus minus 5 equals slope times x minus 0. So I picked that one because when I distribute this, negative 9 times 0 is just 0. So y plus 5 equals negative 9x plus 0, which is just negative 9x. So now I can subtract 5 from both sides, and I get y equals negative 9x minus 5. In number 34, I'm going to do the same thing. The slope is 0 minus minus 3, and negative 2 minus 0. So that's positive 3 over negative 2. And I'm going to plug in to point slope. So y minus 0 equals 3 over negative 2 times x minus minus 2. So y equals negative 3 halves x, and I change that to plus. So negative 3 halves, or 3 over negative 2 times positive 2 is minus 3. So there's my answer. In number 35, we're going to solve a system by graphing. So we have to graph each line. X equals 4, if you remember, that is a vertical line over here at x equals 4. Then y equals 3/4 x plus 1. You just go to positive 1, that's your intercept. You make a dot, and that's your starting point. You go up 3 and over 4. You rise and run. So there's 2 points for your line. And use your straight edge. And those 2 points meet. Remember, the solution to an ordered pair is the place where they meet. So add 4, 4 is the solution. Number 36, to graph y equals 4/3 x plus 3, I would go to positive 3, and since rise 4, run 3 is off the graph, I mean, I could plot it up here, but it's probably better to go down 4 and left 3, because down 4 and left 3 is an equivalent slope to 4/3, so down 4 over 3, and then I've got that line. Then to graph the other one, I go down to negative 2, that's my start point. Negative 1/3 goes down 1 and right 3, or up 1 and left 3. And so those 2 lines are going to meet over here at negative 3, negative 1. And that's the solution to that one. And number 37 is going to be the same process. So x minus 3, go to negative 3, and then the slope of that one is 1 over 1. So we rise 1, run 1, and then we make our graph, and then 6x plus 2. Well, again, if I go up 6 and over 1, that's going to be off the chart, so I'm going to go down 6 and left 1. Once I see where those lines meet, it's right there at negative 1, negative 4.